Hello, everybody. I'm here to welcome you again for September's webinar with Sunita Darby, who's the VP of Sustainability of Spiber America. She's going to be telling us about benchmarking, storytelling, and mitigating, how Spiber, a cutting-edge biotechnology company, applies LCA. Sunita Darby received her BS from MIT and a PhD from Caltech in materials science, where her research focused on renewable energy technologies. After Caltech, she moved to Japan to work as a material scientist at Spiber Inc. Now, Sunita leads Spiber's environmental footprint management section. She's the team responsible for Spiber's first LCA report. She's also responsible for coordinating across the Spiber group to develop and implement the company's environmental impact mitigation strategy, including its climate transition plan. She and her team focus on quantifying and reducing the environmental impact of Spiber's protein fiber production process, while also supporting external communication about environmental benefits to communicate the value of brewed protein material. Welcome, Sunita. Take it away.
Thank you very much for the introduction, Holly. I will, be talking about how Spiber uses LCA today. Spiber is a biotechnology company that produces man-made proteins, and our specialty is kind of the design and molecular engineering of a variety of nature-inspired proteins. So we're fully vertically integrated from genetic engineering through creating products from the proteins that we manufacture through a microbial fermentation process. We were founded in 2007 by some recent graduates from the Keio University Institute for Advanced Biosciences. And that's actually why we're located where we are in the rice paddy ringed city of Tsuruoka, about an hour's flight north of Tokyo. So our founders started out trying to make natural spider silk in a lab. You can't really farm spiders because they eat each other and their yields are low, but spider silk is a really amazing material. It's very tough. That means it's both strong and elastic, so it can absorb a lot of energy before it breaks. It had been a target of material scientists for a long time, and around the time that the company was founded, advances in genetic engineering were kind of opening up new options to try and make it synthetically. So they set out using DNA pulled from natural spider silk sequences that's found in spiders and putting them into microbes that were effectively providing a polymer production factory in a cell. So that DNA sequence provided a program for the cell machinery to replicate those proteins. Basically, all that needed to be provided was energy in the form of sugars for the microbes, as well as some trace nutrients. And the output was the target protein. Well, trying to recreate natural spider silk, there were a couple of challenges, and a couple of the big ones were scale. So what you see here were an early vial of natural spider silk recreated through this microbial fermentation process, and some early spider thread made that way. And another major issue was moisture susceptibility, which can be an advantage for spiders, but quite a disadvantage, for example, for textile materials or materials for other industrial applications. So over time, the strategy shifted from recreating natural material to taking inspiration from natural material and making novel proteins through novel genetics sequences that were inspired by nature. And there's a lot to be inspired by when you look at natural structural protein materials. So you can think of the incredible softness of cashmere goat's hair, the toughness of spider silk, the incredible elasticity of resin found in the tendons of many insects, and even to very, very hard material found in the sucker rings of some squid. So we made that shift from recreating natural protein polymers to making what we call brood protein, which is our kind of umbrella branding for proteins designed using our design and production platform. And so the process for making our material is the same as it would be. So we're still using a genetic program, this time that we've designed, putting that into our microbial host cell, feeding sugars and nutrients to those cells so that they grow, multiply, and produce our target protein. We can then take that protein polymer and make a variety of things. We've demonstrated making everything from gels to bulk materials. But at this time, our commercial focus is on fibers. And in order to go from our protein polymer to textiles, we first carry out an extrusion process, which I will be referring to as fiber spinning during this talk. So I hope that won't be confusing. So we take that fiber and we can cut it and process it to get fluff that kind of resembles what you might pull off a cotton plant after cleaning. So this fluff can then be spun into yarn. So this is more conventionally what people think of when you hear spinning, is making yarn. Then brood protein material can be woven or knit into textiles and undergo typical textile processing like dyeing and finishing. Here you see a photo of just one example of a product that the Goldwyn, which is a Japanese company and brand that actually owns the North Face brand in Japan. They launched using our brood protein material. This was a limited launch material in 2020, but if you look Spiber up these days, you'll see quite a variety of products and concept launches, including some that are available for commercial sale today out in the world, which is very exciting. So we have a few different operating scales these days. We have a research lab in our headquarters in Tsuruoka, Japan. We also, on that same site, have a pilot fiber production and polymer fermentation facility that can make single tons per year. We also have an operating commercial plant. We call this a demonstration plant because it's relatively small scale for a commercial plant, but it's still a couple of orders of magnitude bigger than our pilot facility. And this started commercial operation in 2022. And we are looking ahead to another increase of order of magnitude to production in the United States with ADM at their Clinton bio facility to be started in the next few years. So sustainability had always been important to our founders and early members. And as we got to the point that we were planning for our Thai facility, we wanted to make sure sustainability was part of the conversation. So we started doing some in-house LCA. This was kind of early days. It was a side project for some researchers who had day jobs in the company. And there wasn't a lot of a high level of LCA expertise at the company, but we were able to make some models and get some rough ideas about our impact. But as our Thai plant planning advanced and we got to the point that we were breaking ground and thinking about selling the material coming from that facility, we started thinking more seriously about conveying potential sustainability benefits of our material as a marketing selling point, and also making sure that we weren't operating on hunches, but really had rigorously studied the environmental impacts. So it was at this stage that the person who is now my manager, who's effectively kind of the CSO of the company, came to me initially to talk about procuring renewable energy, but then also wondering about life cycle assessment and taking our in-house life cycle assessment to the next level. He was eager to compare our material to cashmere because we had access to some data in the HIG MSI, which is a textile industry, kind of industry association collaboration that came from the Sustainable Apparel Coalition. They are collecting data from a variety of raw materials and processing methods to create a tool to unify the way the industry is looking at and thinking about environmental impacts, and they use LCA. So there we had some access to compare to wool, for example, but we knew that the yield of cashmere goats was quite a bit lower than sheep producing wool. So we had a hunch that, our putting our best foot forward would be comparing our product to cashmere. So looking in the literature, I didn't find any there. So we spent a while scratching our heads. Do we go find an academic who specializes in, measuring goat farts? What do we do? So what we ended up doing was finding Earthshift Global. We started out by getting some coaching on carrying out proper LCAs and came to the conclusion that what we needed to do was do a comparative study that was not necessarily based on measurements of goats that we commissioned ourselves, but drawing on literature. And so Earthshift Global carried out the study on cashmere and merino wool for us, and we carried out our in-house study on brood protein fiber production, and we put those two together into a full comparative study that was critically reviewed against ISO 14044. And the results I'll be showing you today are from that study. So going in, as I mentioned, we had some inklings. We thought our polymer production was probably higher impact than our fiber spinning, that electricity was really driving things, and that cashmere seemed worse than wool production. We knew that we wanted to be able to make public comparative claims. We knew we wanted to learn how to do this so we could keep doing it in the future. And we knew that we wanted to dig into our hotspots and improve, and also to submit our data to the HIG MSI. In order to kind of better understand our process and to future-proof our study a little bit, we knew we couldn't just consider one production scenario. Our Thai plant was under construction. Our USA concept was in early engineering stages. We wanted to future-proof what we were doing a little bit. So we ended up making our best guesses for 4 business relevant scenarios, production scenarios. And we tossed in one super high yield scenario for fun. We modeled each of those scenarios, both using local grid electricity and also using assuming 100% renewable electricity, which we assumed was somewhat arbitrarily coming from solar photovoltaic energy. And we felt like that was kind of the best overview we could get of varying all of these parameters that we felt impacted or could be impacting our environmental impact. In collecting the LCI for this study, a lot of our inputs for our brood protein, polymer, and fiber production models came from engineering designs, our cost modeling, and our supply chain management team's procurement planning, especially for fermentation. And then looking at fiber spinning, we also were getting input directly from our R&D and operations leaders. Whereas for fermentation and purification, we had kind of a backstop of our pilot plant operation data to fill in gaps. For cashmere and merino wool, as much as possible, the data came from kind of national, international inventories, things like the UN FAO reports and data collection, and also peer-reviewed literature. When there were gaps, there were some items that needed to be filled from non-peer-reviewed sources as well. We, as I mentioned, our functional unit was 1 kilogram of staple fiber for each material. It was a cradle to gate study. And part of the logic for doing a cradle to gate study was that we are a B2B business. We are providing our material to other companies who will then do further processing that we can't fully anticipate. And we don't necessarily have visibility into the use phase. And this is kind of the premise of the Higg MSI. We're sharing our data with the next part of the value chain. But then additionally, we are also comparing with other protein fibers. And so in many ways, there are chemical and functional similarities that led us to assume also that the end of life would be similar and the use phase and further processing could be considered similar. This is, of course, an assumption. You don't necessarily treat a cashmere sweater identically to a wool sweater, but at first approximation, all 3 are protein fibers and share some similarities. The sheep and goat systems produce co-products, milk, meat, and leather, in addition to fiber. So we explored allocation factors. This was a major methodological choice for the study. In the results I'll be showing, the product environmental footprint suggested allocation factors for sheep and goats are used. These are based on energy requirements to produce each co-product. But I will dig into that a little more. For our impact assessment, we used the recipe midpoints and endpoints, used Tracy for sensitivity analysis. Both are relatively well-known and comprehensive, which was, and relatively up-to-date, which was part of our motivation for focusing on recipe. The Higg MSI has its own set of 5 metrics that it uses as well. So those were also important for us to model. So digging into the results, I'm showing you here in dark green are uh, baseline brood protein production scenario, assuming use of renewable electricity, then assuming the use of grid electricity, then merino wool and cashmere, assuming PEF allocation. I will say, actually, we embarked on this study in 2021. So the baseline scenario, production scenario, as of 2021 and in our full report is no longer the one that we consider our baseline now. So I'm showing you the results for our baseline circa 2023. So it definitely was valuable to include multiple production scenarios in our study for that reason. Looking at water scarcity and land use impacts, you can see, and eutrophication as well, you can see that both scenarios for production of brood protein fiber have lower impact than both animal fibers. Of course, from my vantage point, that's the story I like to be able to tell. But we, for better or worse, did not have a simple, clean story we could tell. Looking at the global warming impacts of production in these 4 cases, you can see that while both scenarios of brood protein production have lower impact than cashmere, at kind of at best, brood protein made with renewable electricity is about the same as merino wool production in climate impact. And looking at fossil fuels, our impacts are, at best about the same as cashmere. So in thinking about communicating this story, we had a challenge, and even in digesting the impacts ourselves, we had a challenge. So the next thing we looked to was endpoint indicators. Oh, I am missing a photo credit here. This is, of course, based on a diagram from the recipe developers. So just showing you that endpoint indicators, which we looked to next, link those midpoints via a damage pathway to something we care about protecting, for example, human health. And so looking at our endpoints, our endpoint outcomes, the story is a little bit similar. We're, in a sense, we're trading off energy usage for natural resource consumption. The animal fibers, they're using a lot of land, they're using a lot of water, which has quite a bit of ecosystem and human health impact. The impacts of brood protein production are comparable to that of merino wool in ecosystems, but quite a bit lower than cashmere. With human health, again, quite a bit lower than cashmere, but kind of in the same territory as merino wool. But then when we look at resource consumption, which is really driven by fossil fuel usage, we see large impacts for brood protein. So endpoints do help us underscore the message that brood protein has a number of environmental advantages over cashmere. However, it is still a little bit of a complex story, and endpoints are a bit, have a higher degree of uncertainty. They're a little bit more difficult to explain to a lay audience what is packaged into these. And also there are some value judgments contained in taking a model this far away from where it starts. We also looked to normalization. So what you're seeing here, 100% on this graph would be 100% of an average person's impact on a given metric in a year. An average person being, the total impact of the human population divided by the human population. So there probably aren't any of these average people running around. And the plots show the impact of producing about a sweater's worth of each fiber, or about 200 grams, about half a pound. So again, we see that cashmere's impacts are really, so these are the 8 highest impact categories among the 3 fibers. You can see that cashmere is really dominating the impacts here, but we did have a surprise indicator for us, one we would not have looked at if we hadn't looked beyond the indicators included in the Higg MSI. So that again kind of complicates our ability to tell a simple story about the impacts of brood protein versus the animal production versus the animal fibers. But we can see, a lot of room for telling a positive story here. Another factor that's important is the robustness of the results, of course. And as I mentioned, allocation method is a really significant methodological choice given the co-products of raising those animals. So looking at each pairwise comparison, meaning brood protein fiber production using renewable electricity versus merino wool, or brood protein fiber production using grid electricity versus cashmere. In each of those pairwise comparisons, about 2 to 4 of the 18 indicators in the recipe suite switched kind of which fiber had higher impact when the allocation method was changed. So I have global warming potential plotted here just because it's a very high salience issue for a lot of people. So looking here, you can see that comparing brood protein and cashmere, while brood protein fiber produced using renewable electricity is lower than all scenarios of cashmere production, when we look at brood protein fiber produced using grid electricity, we fall within the range of values, though on the lower side, we fall within the range for cashmere. Similarly, comparing with merino wool, while using grid electricity, we have higher impact than all scenarios. Looking at renewable electricity, we have about the similar impact to merino wool production when modeled using those product environmental footprint, biophysical allocation factor metrics. Here you can just see a graphical representation of the differences among the different allocations. So you can see there's, for example, quite a big difference in what's allocated to fiber in the various allocation methods. So in thinking about how to communicate these messages to the general public, to our direct buyers, and to our potential investors or existing investors, for example, we have, I think, the challenge many of you in the audience might have of balancing telling a story that has value in, that can generate value for the company and the brand, while maintaining transparency and also being comprehensible. So I'm going to share just a couple of examples where we have shared our LCA results in a couple of contexts. And I'm honestly very excited to hear your feedback on these if you have thoughts or criticisms of how we've handled this. So this is a page from our brochure that we make available at trade shows to potential buyers. And so here we are again showing greenhouse gas emissions. And sorry, let me zoom in on this a little bit so you can see it a little better. So we're showing the cashmere and wool, our own, so this is our, sorry for swapping on you, this is the 2021 baseline grid electricity scenario. And then we've included the renewable electricity scenario as along with other targets. So we've made a net zero target for 2035. And we've also announced in our first sustainability report a target of aiming for an emissions intensity of 10 kilograms CO2e per kilogram fiber in a production by 2029. So, in the footnotes, we try to capture a lot of what has gone into this model that may affect the answers, what metric we're using, the allocation method, the fact that this is cradle to gate, and included, appropriate links to our website. But there's still a lot to capture. And of course, the marketing message we want to be conveying is look at that downward trend and, look at these guys looking much higher than we will be. So we've also put out a one-pager of highlights from our critically reviewed report. And, we kind of assume, all right, maybe the lay reader is looking up at just taking a quick glance at, oh, okay, much lower on various points. But we've tried to include kind of the detailed information in this, quarter of the page that we've dedicated to footnotes. And this is kind of the information we're putting in there, kind of the assumptions, the scope of the study, the fact that this study was carried out pre-production before we had measured data from our facility. And you can access this PDF on our website at the link below, as well as some of our other materials. And then, so yeah, I'm very interested to hear any thoughts on how we're making that balance. I think probably the most notable thing here is that we've entirely left off our grid scenario. You can see our little caveat up here as well. These are future projections, but we are hoping to kind of convey the potential, which I think is important for our company. So then the final thing that we've put out into the world based on our full comparative study is a summary report. So we intended it to be general audience friendly. It's about 15 pages long. And, our PR team took a look at it and said, nope, this is not for lay readers. And they're probably right. It's not for casual readers, but for interested people out there. It's intended to be easy to understand by someone interested in figuring out what we've done. And so there we included quite a bit more information, including that data I shared on the allocation method dependency. And we also looked at our different production scenarios. And so here I'm showing you, what I was referring to is that initial baseline from our full comparative study, and as well as this high productivity case that we're now using as our baseline circa 2023. The main reason we transitioned here is that we implemented a waste recovery and reuse system in our fiber spinning process, which is the cause of this significant change in water scarcity impacts. So you can see in the case for our 2020 baseline, both with grid electricity and with renewable electricity, the water consumption is quite a bit higher. And then once we put that circulation system in place, that water consumption goes down significantly. So that made quite a big difference. And we felt that the high productivity scenario was thus more representative of today's production. And then you can also see for some metrics, for example, ecotoxicity and climate change, there's a very significant difference between scenarios where we're assuming grid electricity and scenarios where we're assuming renewable electricity. So this was a major driver that we expected, and was borne out by the study, the detailed study. And I think the final thing I want to point to is looking at the eutrophication metric. Regardless of the scale of production, we don't see a very large difference. And even with renewable electricity, we don't see a huge change. So we're going to have to dig further here into impacts and potential remedies, which of course is the next thing moving forward. Digging into hotspots after the first one or two more obvious ones. We've started doing regular monitoring, and we are kind of collecting monthly LCA data to keep track of our impacts on a more regular basis, and to track any differences between our pre-production modeling and now our production reality. We've started forming some working groups across the company to target reductions in specific areas. So I'll walk you through just briefly the contribution analysis for each of the three materials. When it comes to the animal fibers, supplementary feed really drives the impact. And then looking at climate change, the sheep and goat rearing itself. So this is mainly methane emissions from ruminants, so the burps, and then also manure-related impacts have a good bit of impact. And basically this is similar to the alternative protein versus traditional meat narrative, where it just takes a lot of agricultural output to maintain an animal in order to generate the products that we use from them. In this case, the supplementary feed is actually a minority fraction of what the animals are consuming, but even that minority fraction still requires a large amount of agricultural input. And, you know, you can imagine that as production numbers go up, or as climate destabilizes kind of traditional grazing land, that supplementary feed amount could potentially go up as well. Looking at the drivers for brood protein fiber production, if I were plotting the grid scenario here, about 70% of most of these bars would be electricity and the grid fossil fuel consumption to create that electricity. So I'm showing you the renewable electricity breakdown here so that we can see beyond that. And you can see here, it's the raw materials for our fermentation and purification that's driving eutrophication and ecotoxicity impacts. And it is our heat from fossil fuels. So this is basically process heat in our fermentation, purification, and spinning processes that is dominating global warming potential impacts. Our water scarcity has a large negative component because there's quite a bit of wastewater that is treated. And so taking in dirty water and releasing clean water has an environmental benefit, which leads to a negative, but the net is positive consumption of water. So looking here, we're working with a variety of working groups across our engineering, R&D, and procurement teams to come up with actionable items to decrease each of these bars. We currently have, as I mentioned, formal climate targets, but we are working on setting a wider suite as well. And using LCA to kind of guide our thinking in where it's most important for us to set targets and how achievable different targets may be. I think with climate, there is a lot of support for how to measure, how to analyze, how to think about that. And that's probably also true for things like water footprint. But as you saw, for example, one of our highest normalized impacts is in toxicity deep in our supply chain, likely due to infrastructure in our supply chain. So it's not quite as easy to go to existing tools to understand how would we go about setting a relevant target and how would we go about working towards it. So we are trying to be creative looking at our LCA results to work towards lower impact with the target of being able to tell a simple story that we're better in every way than the animal fibers, for example. As a bio-based, biodegradable material, I think one final opportunity that I'll talk about, and this is actually kind of the next major LCA study we're embarking on right now, is so we are not traditionally, we have not developed a traditional recycling process for our material yet, but we have demonstrated ourselves in-house and are working to think about scaling up a biological upcycling pathway where we can take in digested nutrients. So these can come from textile wastes, for example, waste cotton or waste man-made cellulosics, as well as waste protein fibers, break them down into their underlying nutrients and use those as inputs to our process. Of course, here we've got trade-offs between energy inputs to carry out this whole process while avoiding new virgin inputs. So we are trying to understand under what conditions it makes most sense to pursue this process, but we see this as an interesting opportunity for us to allow a new circular pathway in the textile industry. So I will conclude with that. I see there's some questions in the chat, and I'm excited to have a bit of a conversation. And please do feel free to reach out either directly about sustainability related topics by email or through Spiber's contact form for anything more general. We're very happy to have a conversation.
Thank you, Sunita. What an interesting talk. And now I'm happy to have Juanita Barrera, one of our senior sustainability analysts, ask your questions to Sunita for you. Go ahead, Juanita. Thank you.
Thank you. Thank you, Holly, and thank you, Sunita, for sharing the results of this study. One of the questions that we are getting from our audience is, where is the biggest problem you face in LCA when you discuss this with brands or with your clients?
So I think being able to distill a simple message is really the hardest thing, because there are so many, we can draw a box around certain metrics and say, look at this really positive impact here. But all those caveats of we've done a study this way that can affect the results, make it challenging to balance that positive storytelling with making sure we're being transparent and complete enough with the information that they can make their own judgments. And I think we've tried to err on the side of transparency. So, for example, with direct consumers, in the end, we decided to post a summary report on our website, but our full report is something that is shared with brands, and they're able to, for people who are wanting to see, to crack open the model and really see everything that we've done. we try to share with them. And for those who don't, we hope that our summary report was able to be a little bit of a guide for how to understand what we've done. We tried to use that as our best tool.
Thanks, Sunita, for that. And yeah, like a key thing has been really transparent with all your stakeholders and sharing the results and all the assumptions. Another question that we are getting from our audience is if you are planning to conduct any social assessment. And this part is you're presenting today the life cycle assessment results, but how about the social part of the study?
So what we have been focusing on in terms of social impacts has primarily been through our sustainable sourcing efforts. So we've carried out human rights risk assessment on our supply chain and are tracking kind of course, in-house kind of data on our employee well-being and things like that. But we have not considered really doing a social LCA. I think we've got those in different brain space right now. And I think we recognize that in our supply chain, the highest risk areas are really coming from our sugarcane sugar sourcing for feedstock in our Thai facility. And so that's an area where we know it's a hotspot and a driver, and we are working to engage our supplier and to get involved in that supply chain. But I don't think we have plans to maintain that periodic risk monitoring in our supply chain, but I think that's where we are focusing social assessment.
Okay, thank you. Thank you, Sunita, for sharing that. Also, during your presentation, you mentioned that you're looking to mitigate the impacts from your process. Can you talk more about what are the measures that you are taking or the plans that you have for the future to reduce those environmental impacts?
So, as I mentioned, global warming potential, climate impacts are the first place where we have set specific targets and are really diving in. So we're working to, electricity being the biggest portion, we're working to directly procure renewable electricity. Unfortunately, the financial feasibility, for example, of VPPAs in the United States have been quite a bit in flux in the last couple of years with COVID and supply chain constraints. So our target for that is between 2025 and 2027. We know that the next largest contributor is kind of process heat. So we're working with our engineering team to explore alternatives like procuring biogas as an alternative to conventional natural gas, and to explore potentially electrifying our process heat generation. We're in early stages of putting together our roadmap to net zero right now, and looking beyond that with our supply chain management team to consider kind of ingredient by ingredient, where do we have enough leverage to either work with a specific supplier to first get their primary data to understand our own supply chain's specific impacts rather than the secondary data from, for example, EcoInvent and the Sphera database. And then also looking at, in collaboration with our R&D teams, where are the highest priorities for trying to decrease use of a given ingredient in our supply chain? So that's kind of the process we're going through with specifically climate change, and looking at other indicators. I think our highest priority is first to understand the reality of our production, because since our model was made pre-production, there were some areas where the input LCI was a little more speculative than others. So we're going back, collecting measured data, and looking then to our real supply chain to confirm that, for example, that human toxicity number is as high as it seems to be.
Okay, thank you, Sunita. Seems you have a lot of work to do. And on that, another question that we got is, this LCA that you presenting here is cradle to gate. How do you expect the impacts will change, or how those will look like when you are including or when you are doing a cradle to grave study?
So, as I mentioned, I think the biggest kind of aspects in comparison to other protein fibers are probably pretty similar. They're organics. So going into a landfill, for example, they would likely be generating methane. Going into a more aerobic biodegradation situation, the end of life is similar. And the use phase, it kind of depends on the product. With the use phase, because of where we are in development, it's a little bit hard to know fully how brands will be using our products. We've got a few early stage products out in the world, but in a certain sense, they're hypotheses. Those products are hypotheses of how people will take and use brewed protein fiber in the world. And so I don't think we have full knowledge to understand, how durable will usage be. People think of wool garments, for example, as something that you treat as a durable good and you keep them a long time. Whereas a polycotton t-shirt is you have it a little while. It's something you use for a shorter lifespan than your nice wool socks. And so we still need to see how people use our material and the products made using our material to be able to properly model the use phase. I think, we've compared 1 kilogram of each fiber, and that's an assumption that needs to be reevaluated as our sales increase and there are more and more people who are employing our product in real use cases, whether it's a reasonable assumption to be replacing, 1-for-1 brewed protein to cashmere or 1-for-1 brewed protein to wool. And I think there's, opportunity in comparing to maybe more synthetic fibers or non-biodegradable fibers, because at the end of life, we are trying to create a circular model. So I don't know that I can predict what the impacts would look like, but I think those are a few of the important issues that we're thinking about as we think about extending to a cradle to grave model.
Thank you. And now moving into the questions of like the other material that you evaluate on this LCA, can you please explain why Australian merino has less impact than cashmere?
So just at a very high level, the yield from one animal in a year is about 10 times as much from sheep than from a goat. And so that's kind of at a very simple level, the big difference.
Okay, well, we have so many more questions here that we don't have time to answer right now. So people in the audience, if you want to just send your question, any more questions to Sunita, I know she'd be happy to answer them. And want to thank both you, particularly you, Sunita, for a great webinar, and thank you, Anita, as well. And I'll stay tuned for next month's webinar. Goodbye now.